Hello all, this is Dr. A. Anuja, Assistant Professor, Department of Mathematics, Arulmigu Palani Andavar, Arts College for Women, Palani. In this lecture, we are going to discuss about graphs and their basic concepts. A graph G consists of the pair V of G, X of G. Here, V of G is a non-empty finite set, which set contains the elements. These elements are called the points or vertices. And the next one, X of G, is a set of unordered pairs of distinct elements, which means different elements of V of G. This X of G is called the lines or edges of the given graph G. If we denoting this, X is equal to set of UV, which belongs to X of G, and the UV is form the line, though that line name as an X. So the line X is said to join U and V. So we write X is equal to UV and we say the points U and V are adjacent. Now the point U, the line X are incident with each other if two distinct lines X and Y, which means two different lines, one line name is X and another name is Y, these two lines are incident with a common point, then they called the adjacent lines. And a graph with P points, which means P vertices, and Q lines, Q edges, it's called an graph. How will written in the form of graph means P comma Q, and this P is represent the vertices and Q is represent the edges. When there is no possibility of confusions, we write V of G is equal to V and X of G is equal to X. Vertices is denoted as V and edges denoted as capital X. And the examples, let V is equal to set of A, B, C, D. The A, B, C, D are vertices and their edges AB, one edge AC and set AD. So three edges which are contained in X. The graph G is equal to V comma X, which means 4 vertices and 3 edges, that is 4 comma 3 graph. And this graph is given in this figure and they'll denote the vertices name, and AB is on edge and AC is on another edge and AD is also in another edge. And this graph can be represented by the diagram given here. And this graph, a point A and B are adjacent, which means these two vertices are lie on the same line. So the line, which means will give a X line means, and the one end is A and another end vertices is B. So these A and B are adjacent. But in this case, in this figure, B, we are denoting B and C. So these are two vertices are lie on the different lines. So we can say that B and C are non-adjacent. And the example 2, let V is equal to 4 vertices. The name is 1, 2, 3, 4. And the edge set X is equal to 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. So the graph G is equal to V comma X is an 4, 6 graph, 4 vertices and 6 edges. And this graph given in the figure 2.2, although the lines 1, 2, which means the baseline 1, 3, which means the diagonal lines 1, 3 and 2, 4, they are intersect, which is shown in the figure 2.2. They are intersect, it's not a point of the graph. So here in this graph, the line 2 to 4 and 1 to 3, they are intersecting at only one point. So that point does not consider the vertices of the given graph. So in another diagram for the graph given in figure 2.3. So the graph is 10, 15, which means 10 vertices and 15 edges. It's called the Peterson graph. And the remark, the definition of a graph does not allow more than one line joining 2 points in the figure. and it also does not allow any line joining a point to itself. So loop means the line joining a point to itself means we can say that is a loop. And the next, the definition: if more than one line joining two vertices are allowed, the resulting object is called the multigraph, which means more than one lines joining the two vertices. So this graph is allowing, we can say that graph is a multigraph. And another one, lines joining the same points are called the multiple lines. The more than one line joining a two vertices, multigraph. Line joining the same points, the multigraph means it is called a multiple line. If further loop or not or also allowed the resulting object, it's a pseudograph, which means more than a one line. In example, a multigraph, for the multigraph will give a one example graph in a figure 2.5. So in this multigraph, more than one line joining into the two vertices. Okay, and the figure 2.6 is an example for the pseudograph. And the figure 1.2, which means the Cambridge figure problem is a multigraph. Already we discussed in that graph. And then remark, let G be a P comma Q, and P is represent the vertices and Q is edges. Then Q is less than or equal to P2 and Q is equal to P2 if and only if any two distinct points are adjacent. And the next definition, a graph in which any two distinct points are adjacent, it's called a complete graph, which means every points are connected with the lines. So a graph in which any two distinct points, it must be in a different points, are adjacent is called the complete graph. So for we denoting the complete graph as an KP. So the complete graph with P points is denoted by KP. And K3 it's called a complete graph. Their example is triangle. So triangle, it has a three vertices and the three lines. So the triangle, it's one of the example for the complete graph. It's denoted as K3. And the next one, in the figure 2.3, the triangle shaped, it has a four vertices and there are five lines, edges. So K4 and K5 is shown in the figure 2.3 is an K4, four vertices. It's a complete graph. It is K4 graph. And the next one, figure 2.7. Here, this is an example for the complete graph K5. And the next definition, a graph whose edge set is empty, it's called a null graph or it's called a totally disconnected graph. And the next definition, a graph G is called labeled if it is P points are distinct from one another by the name such as V1, V2 and so on VP. These are the vertices name. And the graph figure 2.1, this one, and 2.3 and this one, and these are the labeled graph. And the figure 2.7 above the definition, it's unlabeled graph, which means P points are distinct, the vertices are distinct from one another. So that is the main conditions for the labeled graph. And the next definition, bigraph, a graph G is called a bigraph or bipartite graph, which means the partitions, the vertices has a two different kind of partition. Those partition has a different vertices. In this definition, if V can be partitioned into two distinct subsets, V1 and V2, such that every line of G join a point of V1 to the point of V2. which means if we the vertices V is splitting into the two set V1 and V2, in both sets has a different kind of vertices. If we take V1 vertices, it must be joined into the V2 vertices. From this concept, we can say that graph is a bipartite graph. So it is denoted V1 comma V2, it's called the bipartition of G. If further G contains every line joining the points of V1 to the points of V2, so then G is called the complete bipartite graph. And if V1 contains m points and V2 contains n points, then the complete bipartite graph G is denoted by Km comma n. Already we told complete graph is denoted as Kp, that the graph is only has a p points, and in this bipartite graph we are splitting into the two vertices concept. So the V1 has a m vertices and V2 has a n vertices. M vertices should be connected with the n vertices. This graph is called a complete bipartite graph, which is denoted as Km comma n. And the graph given in the figure 2.1, it's 1 comma 3, and the graph given in figure 2.8 is a 3 comma 3, and K1 comma m, it's called the star for and m is greater than or equal to 1. Thank you.